Well, hello everyone and welcome. Today I'm going to show you how you can create a MNIST program using support vector machines. So pretty much giving handwritten digits, it's able to guess what the number is with a certain level of accuracy, right? So rather than me just talking about it, why don't I show you first of all? Let me just open up my command prompt and let me just clear that stuff out and run MNIST underscore model file, which is the name of my model file. So let me just run that and wait for it. As you can see, it predicts this number is a 7 and it is actually is a 7, and this time it predicts this is a 2 and it actually is a 2. This time it predicts this is a 1 and it actually is a 1, and we will keep going. This time it is 0 and predicts this is 0, and it will keep guessing what the number is. So this time it is a 4 and predicts this is a 4. So yeah, this time it is a 1 and it predicts this is a 1, and yes, that's how this whole thing is going to work. So I'm not going to run it because the length of the entire has dataset is about 10,000, so I'm not going to run 10,000 times. So let me just close that. So yes, this is the thing for the model, and yes, this whole thing is just done in 30 lines. And yes, this is handling my MNIST model as well, so that is really short and cool. But this is not the thing that I want you to show, because anyone is able to create it in just a 15 minutes. So I wanted to show this GUI.py file that I have created with myself using Pygame, and yes, only using Pygame. So let me just clear that stuff out and run GUI.py file. As you can see, Pygame loads up, and in here you can draw any number between 0 to 15 and it will guess what the number is. So yes, that is really cool, and but this thing doesn't work very well. And let me show you guys why I'm say that. Let me just try to draw like a 7. Chances are it is not be able to guess this is a 7. And hit spacebar and it predicts this is a 7. So yeah, that's Simon's work. And if I draw like a 1, like a squiggly, no, it doesn't. It is not be able to predict this is a 1. This one predict this is a 6. If I draw like a 5, it predicts this is a 5. So yes, but it fails to detect circular digits like zeros and eights. So let's just try a 0 in here. So like a 0 is like this. Oh, it predicts this is 0. I don't know how. And if I draw like a 2, it predicts this is 2. So perfect. So yes, in this video, you will learn how to create a similar one using Pygame and scikit-learn. So without further ado, let's jump into the video and get started. Alright, we will start the video by installing some stuff here, and just a quick note here. This video is not really designed for beginners. And yes, if you're a beginner, you try to follow along. But this video is designed for someone who know Python very well and someone who know basics of machine learning and artificial intelligence. So yes, and you should know Pygame also, because I'm using Pygame in this video and I'm not really going to explain how Pygame works. This video is really focused on you to build some project using these modules. So yes. So let's start by installation. So open up command prompt, and if you're using Mac or Linux, open up terminal. Let me just make this bit bigger here and type pip. If you're using Windows, type pip3. If you're using Mac or Linux, and type install MNIST. What MNIST is, it just gives an MNIST dataset for building this kind of MNIST models. So yes, we need that. So let's install that. As you can see, I already have installed it, but you guys should go through the installation. Next thing I want you to install is Pygame. So I'm going to say pip to install Pygame, like that, and hit enter. And I already have installed it, so yes. So let me just cut that. For the purpose of this tutorial, I'm going to use Sublime Text, but you guys should use any code editor you want. It doesn't really matter, but we should need to install one more thing in here. So we need to install Anaconda. What Anaconda is, it just gives some libraries, tools and libraries to building data science and machine learning projects. So yes, we need that. So let's open up your favorite browser and search for Anaconda download. Go to individual editions, scroll down to the bottom, and click on this download button. And in here, download the Anaconda installer for your operating system. If you're using Windows, you should click on this link. If you're using Mac, you should click on this link. And if you're using Linux, you should click on this link. I'm not going to install it because I already have installed it. So let me just close my browser here. And let me just close this extra command prompt window. And yes, let's dive into the code. So let's start by importing some stuff. So I'm going to say import MNIST, and next thing I want you to import is sklearn, which should come with Anaconda. So I'm going to say from sklearn dot svm import linear svc. What linear SVC is, it just gives the SVM or support vector machine algorithm for building the model. So I'm going to say now we need to get our data set. If you're not familiar with the MNIST, it come with two parts, one for training, other one for testing. So we need both of those. I'm going to say x underscore train is equals to MNIST dot train what the heck, there you go, underscore images. And next thing we need is our label. So I'm going to say y underscore train is equals to MNIST dot train underscore labels, like that. Next thing we need our testing data set. So I'm going to say x underscore test is equals to MNIST dot test underscore images. And next thing are testing labels. So I'm going to say y underscore test is equal to MNIST dot test underscore labels, like that. And let me just show you what these images and labels are. So let me just print xtrain at the index of 0, and this xtrain, and actually all of these things is just numpy array. So we need to print this first instance, and next we need to print is r label. So I'm going to say y train at the index of 0, always the first index. So I'm going to say in here I'm going to run this model.py file. As you can see, we get a pretty great chunks of 0, but these are actually the pixel values of each pixels in the grid. And as if you notice, the grid are, if you notice, this is actually two-dimensional array each, and in this array uh, each array is representing the first column or the columns on the grid. So yes, and these numbers are just the pixels value, nothing else. And down here we get a label 5. That means this number is actually is a 5, and as you guys can see, this is actually forming a pattern like 5. So yes, that's how the MNIST data work. So let me just go back to my Sublime and clear this stuff. Now we need to shape our dataset. Let me just show you why. So I'm going to say print the whole X train. So let's save that and clear that stuff and run again model.py file. As you can see, we get up again chunks of zeros. And if you guys notice, this is actually three-dimensional array. But the problem is the MNIST, not MNIST, sklearn doesn't really understand three-dimensional arrays. So yes, we need to shape it in 2 dimensions. So let me just start shaping the data set now. So this is really easy. So I'm going to say n and underscore samples nx and ny is equals to xtrain dot shape. What I'm doing here is just unpacking the shape of the dataset into 3 variables. N samples become 60,000 because the length of the xtrain is about 60,000. And again, if you are familiar with MNIST, the length of the entire training dataset is about 60,000, and the length of the entire testing dataset is about 10,000. So yes, this N samples becomes 60,000, NX and NY become 28 by 28. Again, the dimension of each image is about 28 by 28 pixels, so that's why both are become 28. So now we need to shape it. So I'm going to say xtrain dot not dot is equals to xtrain dot reshape, and let me just add another pair of parentheses, and in here I'm going to say n samples and nx times ny. But it just reshape the dataset into 2 dimension. That's all it does. So yes, let me just print that for you guys. I'm going to say xtrain, and before that let's print again xtrain in here as well. Save that and clear that stuff and run again model.py file. As you can see, we get our again the whole 3-dimension array, but down here our array become 2-dimensional. So that's what we do, what we want. So perfect. And we need to shape our testing dataset as well, because if we build a model using this xtrain dataset, this is actually 2-dimensional, and xtest is actually 3-dimensional. So we need to shape it as well. So I'm going to say xtest underscore this time because we need to visualize this. So I'm going to say xtest dot not dot. Let me just make similar variable for it as well. So I'm going to say n samples underscore test nx underscore test and ny underscore test. I'm going to say x test dot shape. Again, I'm unpacking the shape of the x test in three variables, and samples becomes 10,000 and nx and y become 28 by 28 as well. So I'm going to say dot reshape. I'm going to say n samples test. Oops. N samples test nx test times ny test. So perfect, awesome. Now if you print that, x test underscore and clear that stuff and run this model.py file. As you can see, this become 2 dimensions, so perfect. Now it's time for training. So I'm going to say SVM is equals to linear SVC. It's just the name of our SVM object. So I'm going to say now I'm going to say SVM dot fit, and in here we need to fit our training data sets. So yes, I'm going to say x train and y train. Now we need to measure its accuracy, so I'm going to say ACC is equals to SVM dot score, and in here I'm going to say x train and y train. Now we need to print the accuracy, so I'm just print in the string type of thing. I'm going to say ACC and print ACC in here, short for accuracy. So yes, let me just clear that stuff again and start the training process. I'm going to run this model.py file, so hit enter, and it's going to take a while, so I'm going to pause the recording. As you can see, we get pretty good accuracy in here, which is about 87%. Don't worry about 0.87. Actually the sklearn measure the accuracy of a model between 0 to 1, so it is about 87. So yes, and now it's time for save our model, because if you have noticed in this period of time it takes so many time for training, so that's why we need to save that. So to save a model, it is pretty straightforward. We need to import one more thing, which is something called pickle. So I'm going to say import pickle like that, and it should come with Python. And to save a model, and actually what pickle does, it just attempt to save any object. So in this case we need to save this SVC object, linear SVC, so that's why, and it will save the its methods and statement, whatever it is, it just save all of them. So I'm going to say to save a model we need to open a file. So I'm going to say model actually underscore file is equals to open a file called MNIST.pickle, and in here I'm going to say open it in write binary mode, and now I'm going to say pickle.dump, and in here we need to dump our SVM object, which is equals to SVC, linear SVC, and I'm going to say, and second thing is model file. So we need to save our SVM model or object, SVM object, in our model file. So let's save that. But if you are worrying that worry about that it will restart the whole training process, and it is quite possible that we lose that level of accuracy, because we get this time we get pretty good accuracy in here. So to fix that problem, and yes, it could possible, we should lose that level of accuracy. And to fix that problem, I'm going to say, first of all, let me just cut that, and I'm going to say for underscore n underscore n range of 10. I'm going to run this loop 10 times. You will run many times you want, it doesn't really matter. So let's append those, and I'm going to say if ACC is greater than or equals to 0.87, then print SVC, I mean print accuracy, and then save the model. What I'm saying here, if run this loop 10 times, I mean, which means if you are not getting this level of accuracy, then don't save the model, just run this loop 10 times, and it will run the training process in 10 times. And if we get this level of accuracy, then go ahead and save the model. And in here we need to say break, not break, because if we achieve that level of accuracy, we probably want to break that loop. And in here I'm going to say print saving. Just we get some output if we are save that model, and let's save that, and again restart the training process, and again it's going to take a while, so I'm going to pause the recording. And this time we get about 87.83% of accuracy. It is always less than that, but yes, it's all right, it is about 87. So now we don't really need, and actually if you notice in your working directory, you should see a new file called MNIST.pickle that we are created right here. So awesome. Let me just comment that line out, because we don't need to train it again and again, and we don't really need this SVC object, or we don't really need this import statements. And now we need to read that file, so I'm going to say again open a new model file. I'm going to say open MNIST.pickle in read binary mode. So I'm going to specify that in here. I'm going to say SVM is equals to linear not linear SVC, this time equals to pickle dot load, this time load, and we need to load this file. And now we will easily access all of these methods and statements using this SVM variable, or this load, whatever it is. Right now it's time for make predictions. So first of all, we need to visualize that what we are predicting. So I'm going to say from matplotlib lib dot pyplot, not from matplotlib, import pyplot as plt, like that. Now to visualize the model, it is really easy. First of all, let me just make predictions. I'm going to say predict is equals to what you call that, SVM dot predict, and we need to specify our testing dataset that I've created in here. And now I'm going to say for I in range of, because we need to loop through that all prediction and images, I'm going to say in range of length of predict. Now I'm going to say plt dot imshow, and in here we need to visualize our image. So don't specify this reshaped what you call that testing data set, because it throw an error. Instead of that, we need to specify the original one. So I'm going to say x test at the index of I, and I see that's it for it. And I'm going to say print predict with a capital P, and in here I'm going to say predict at the index of I, and at last I'm going to say plt dot show, and save that. And now it's time for running the model.py file. So let me just run that right now and wait for it. And we get an error. It says predict is not defined. So let me see what the heck is that. Oh, so I misspelled predict in here. So let me just make it correct. So I'm going to say predict, and again in here and actually all the thing is fixed right now. So let's run it again. Wait for it. As you can see, it predicts this number is a 7, and we get a pretty decent looking 7, but this kind of weird because we get in yellowish and purplish color. So let me just make this black and white. So to make this black and white, we need to specify a keyword argument called cmap. By default it's set to none, so I'm going to say cmap is equals to plt dot cm dot get cmap underscore cmap. In here, in the quotation mark, type binary. What it does, it just make it in binary format, as binary as usual. So let's clear that stuff out and run this model.py file again and wait for it. And there we go, we get a 7, and it predicts this number is a 7. Next it is a 2, it predicts this is a 2. Next is a 1, is predict this is a 1, and we will keep going. And yes, this time it's 0, and predict this is a 0. And this time it is a 4, and it predicts this is a 4. This time it is a 1, and it predicts this is a 1. So perfect, awesome, it's working very well. No, it predicts a 9, and it predicts this is a 5. So yeah, making mistakes in here. So yes, that's how this thing is work. Let me just close that, and I'm going to wrap this video for now. In the next video we will learn how to create the GUI stuff that I showed you earlier using Pygame. So for now I'm going to wrap the video, and if you enjoy, please make sure to leave a like, subscribe to the channel, and I see you next.